Hi everyone, this is Rohit with an graduate rotational internship program provided from the Spark Foundation for Data Science and Business Analytics. This is the TSF Grip Task #1. So let's look out the task 1. Prediction using supervised machine learning. So what is the problem statement? Predict the percentage of a student based on the number of study hours. This is a simple linear regression task as it involves just two variables. The dataset link provided as here in the red red color, and they have asked one question: what will be the predicted score if a student studies for 9.2 hours a day? So we will now jump into the solution. So first of all, I'm importing some dependencies like libraries from Python, such as pandas, numpy, matplotlib, and now I'm reading the data set through that link which was provided. So let's check out the number of rows and columns. It contains 25 rows and 2 columns. I'm performing a basic EDA on the data set given. So we have 2 columns, hours and score. R is of data type float and score is of data type int. Let's check how the data is described. So as we know, we have 25 rows in each column. The mean of ours is 5 and of score is 51.48 something. Standard deviation is given as 2.52 for hours and for score is 25.28. Minimum minimum hours is 1.1 and maximum score is 17. No, minimum score is 17. Sorry, oops. So the 25% means it is a quartile one. Q1 is also known as Q1. So quartile one for hours is 2.7 and for score is 30. And Q2, which is 50%, is 4.8, and for score it is 47.0, and quartile range 3, which is 75%, is 7.4 for hours and 75 for score. The maximum hours is 9.2 hours a student studied, and the maximum score is 95. So we are checking out for the interquartile range for hours and score, and the formula is Q3 minus Q1, that is 75% minus 25%, and the values are for hours it is 4.7 and score it is 45. Let's check out for the duplicates. No duplicates. Here I'm plotting a graph, studies versus percentage, how the relationship is between the two columns. So from the above graph, it is observed that there exists a linear relationship between hours and score. You can see that it is increasing, it is in the increasing order. Now preparing the data. So I have taken x hours as an independent variable and dependent variable as scores on y. Reshaping the values. Now splitting it into training test data. So I have only separated a 10% for the test set as the data set is too low. We only have 25 records for, so that's why the data is been divided into 22 for training and testing only 3 records. It is enough. So now we are training the model using linear regression. I have imported linear regression from sklearn.linear model and setting a object regressor for the linear regression. Now fitting the model on the training data. So the model has been trained. Let's predict it on the test data. We have three values. Let's check how the performance of the regression model is. Uh, on on R score, it is 0.929, means it is really close to near to 1, and the mean absolute error is 5.399, which is really close to 0. So we can say that our model is well trained and giving some good values. And now I'm checking your regressor line for the data set. This is only visualization part, and for test set, the regression line. So plotting the y test and y predict, plotting predicting the training set, training data set, predicting the training data set, and plotting y train and x train. We have a linear relationship in all graphs. If you see, in all four graphs, we have a linear relationship, and 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 in the last, they have asked us a question about regarding what will be the predict score if the student studies for 9.25 hours per day. So I'm passing it to the variable. The answer is if a student studies for 9.25 hours per day, the predicted score is 93.677. So here the presentation is end. Thank you so much. Thank you.